Does size matter?
Yeah.
Why?
Because you can't mix a stew with a teaspoon.
What's your ideal size?
Like 8.
So what if it's less than 8?
Just as long as it's not like tiny.
What is tiny to you?
4.
4.
We've seen that Java provides us with 8 primitive types in Java. Apart from that, we have the corresponding object wrapper classes, and we also looked at the BigInteger and BigDecimal. Now, if you observe, most code you see in Java are using either the int or the double. Now, why learn about other types, and why does Java offer so many types? Welcome to lesson 37, Does Size Matter? A binary digit or a bit is the smallest unit of data in computing. Now, a bit represents one of 2 binary values, either represents a 0 or a 1. Now, in electronics, you can see that as a 1 being 0 volts and a negative 5 volt giving you a 0. A byte consists of 8 bits. Now, historically, the byte was a number of bits used to encode a single character of text in a computer. I'm sure you've heard of ASCII and Unicode and so on. And for that reason, it is the smallest addressable unit of memory in many computer architectures. Now, there's a constant called bytes from the wrapper classes that you can use to get the number of bits in primitives such as byte.bytes, short.bytes, and so on. Now, to get the number of bytes, and then you multiply this by 8 to get the bits, because as you know, you got 8 bits to a byte. But note that the wrapper class Boolean, BigInteger and BigDecimal do not have the bytes constant. Boolean size is dependent on the virtual machine implementation of the Boolean, and the BigInteger and the BigDecimal size is dependent on the JVM's memory and will throw an exception when the limits are exceeded. What I'm going to do here is write 2 methods so that we can output our types in binary format. It will print them out to the console as zeros. So a byte will have 8 zeros and a long would have 64 zeros, so we can see them visually. Now the format method of the string class, we're not familiar with it yet. Bear in mind, I'm just using it here to format the output in like a tabular form. So I'll be touching on those topics in future videos. Important thing is to see the different sizes of our different types. Note that the minimum size on a 64-bit machine for an object is around 16 bytes. Here I load or open the snippet of code with the two methods. As you can see, there are my two methods, and I'm going to call them. And there's the visual representation, so you can see from the primitive byte to the wrapper integer, the object on the bottom there, big difference in the sizes.
Alright, so I know you guys are going to love this one. Today I'm at the Celebrity Car Museum in Branson, Missouri, and I'm going to show you guys the mini school bus from Dumb and Dumberer. So from the front, this school bus looks like a regular school bus, except when you look at it from the side, yeah, it's not a regular school bus at all, no. Alright, so we're going to go up in it. Look at how small this thing is. Oh my god. Ugh. This is the perfect claw bus. Not a lot of kids, not a lot of noise.
In computer architecture, a bus is a communication system that transfers data between the components inside the computer. Now, in the early computers, these were bundles of wires that attached the computer memory and other peripherals. They were 8-bit parallel buses. And then in second generation, you got the 16 and 32-bit buses. And the third generation, it's like a network-like buses. As we know, a computer uses the binary system to work with data. So this is stored in the computer as zeros and ones. Now 8 bits is a byte, half a bit is a nibble, and 1024 bits is known as a kilobyte. Now these bytes are sent from one component of the computer to the other. In other words, from the CPU to memory by using the bus and so on. Now the bit width of a bus is also known as a word. So the word size of a system with a 16-bit bus will be 16 bits, and that of a 32-bit bus will be 32 bits. How much information can be moved from one component to another in the computer depends on the word size. In other words, if you've got a 16-bit system, you'll be able to transfer in one clock cycle of the computer 16 bits from the one component to the other. Now, a long and a double have 64 bits in Java. On a computer with a word size of 32 bits, these two data types are not treated automatically. In other words, they're not sent in one go, in one read, and so on. So, to write a value in a variable of a long data type, two write actions are performed, one for each 32-bit halves. In other words, in a 16-bit system, you need 4 writes. Now, if you are going to store objects such as the byte, integer, or double, note these wrapper classes are objects, and they carry additional payloads for their headers. So, in a 64-bit machine, minimum object size are around 16 bits. So storing a byte, and I'm talking about the wrapper byte, the capital B byte, instead of its primitive equivalent, is around 16 times more expensive. So by now you've picked up why it is important to pick the right types when writing your application. We saw that the larger the bit size of the type we're going to use, the more memory the system will need to store the type, and depending on your system architecture, you may need more than one read-write operation, thus making the application slower. Now, this may not make a noticeable difference when writing apps that read and write small amounts of data, but with big data there will be a noticeable difference. I hope you've enjoyed this lesson, learned something from it, and please don't forget to press the subscribe and notify button. I've also got a Facebook page related to this channel. You are welcome to join my adventure channel where I share photos and videos of various activities. Until we meet again in our next lesson, I wish you well and happy coding.